Hey guys, so here's an update so far. I don't know which day or which part it is, number 2 or number 3. Okay, so here's my inverter. I put it on the case. I left the upper case of the inverter out because for ventilation. The front, I have a remote on and off for inverter, but this wire was just pushing too much on this, so I just cut the metal and bent it. So I'm thinking putting that at the back to turn the inverter on and off. So I'm gonna have to remove something, probably one of these ports, and I'm gonna use that area for the remote, not remote, but the on and off switch for the inverter. For the BMS, not for the BMS, sorry, my bad, battery. I'm gonna make it through the BMS, of course, with these balancing leads. I opened this metal part out, and then I connected, as in previously I told you guys, main negative. So here's the main negative. It's active right now. It's always active. And there's a main positive. So here's main positive. So that one with these two and these balance leads, I'm gonna have to put the BMS, which has arrived finally. Took a while. And that's why the video had to be put on hold. So this is the front. So I removed the front panel as I showed it previously. So I'm gonna see if the panel of the inverter somehow makes it to this after I put it up here. So I'm gonna see that. It comes close, but I don't know until I put it together. Secondly, I'm trying to put a switch. So here's the switch I have. I think this one is like 60 amps or 80 amps. I don't remember, but I know it's a very thick one. So, and it's only 2000 watts inverter out of 48 volt battery. So that comes up to, something like 50, 60 amps, something like that. Not even 50, 60, it's like way less. But regardless. So I'm thinking of putting this as a main shutoff for the battery. I was thinking to put it up front somewhere here, but the way it is designed, this one, it just comes out too far for my liking. So if I put it somewhere like this, and of course the metal part will go inside, I'm gonna like melt it a little bit or make holes. This is just coming too far out. So what I'm thinking, on the panel on this side, there are some extra connections, 12 volt, and this one is 12 volt out. So I'm gonna remove all that inside, of course, here. So here's the inside. Oh man. So here's the inside. So I'm gonna remove all that, and I'm gonna try to utilize this round 12 volt cigarette adapter thing, and somehow make it fit from the other side out. So this one will be coming out like this. So that's what I'm thinking. This is the best way, I think. And worst come to worst, if this doesn't close, I'll just get rid of it. Doesn't matter. I'll just leave it open. So that's not the end of the world. So this is what I'm thinking. So from the BMS, one wire will go onto this switch, and then from here, the main. I'll use it as a positive. So it will go here, and from here it will go to the inverter. So let's work on that. These two ones you see, they're dead, of course, because they're for the external battery. Which once I remove the back panel, I'll remove those. I already removed the front ones because they were live, and I didn't want to get a spark or didn't want to come in contact with them. So let's do that. So let's open up these side things and remove all the mechanism and try to install this. You don't have to, but I have it, so why not? Okay, so here's what I ended up doing. So here's the switch. I removed the whole mechanism. I think this is part of it, and whatever. The casing is still there. So I just ended up zip tying, wherever I could find the hole. So I only put 3, 1, 2, 3. At the back, I didn't find anything, but it doesn't matter because this is solid. It's not going anywhere. And good thing is this one closes too. is flushed, so it's not coming out too far that this door will not close. Yeah, of course, these are all gone. But yeah, actually, but the main switch that I'm going to be using now as a main power off is going to be underneath this panel. So voila. So now I just have to do the wiring. So let's bring the BMS out and work on the BMS. Or actually, I think I should just put this panel back on with the display, whatever I can do with the display. So and then we'll work on the BMS after. So at least the front side is finalized. For these USBs, there are a bunch of ways to utilize those, because there are like bunch of, if you go AliExpress, there are like bunch of USB modules that you can buy, and then glue it facing that way, of course, and then the wires you can just do a DC to DC converter and then take it from 48 volts to a 12 volt or 5 volt, whatever that case be. But I'm not going to do that. It's just too much work. Plus, once all my outlets going to be active, I can just use the normal charger if I have to. Not that I'm going to be using this for charging the phone or tablets or anything like that, but that is a way to utilize all those USBs if you want to do that. So just a thought, but I'm not going to do that. Okay, so what I ended up doing, once I put that switch, I'm going to utilize the main negative, even though the positive would have been better. But positive is way too far. I don't want to open the whole thing again and then take a wire from here to there, because it's on this panel. This switch is on the other side of the unit. So, but this wire that I put on, it's kind of perfect size. So this is coming from main battery. So as long as you break the connection, that works. Some people may argue, no, positive should have been there, and I agree in a way, but I don't have that luxury right now. So I'm going to utilize negative instead. As long as you break the connection of negative, positive, in the application, so that kind of works. So the main negative is going to go through the switch, and from there I use the 8 gauge wire, which can do up to 60 amps, and it's going into the BMS. And we will work on the BMS later, because there's a connection wires for the balancing wires. So we will work on that later. But for now, I'm gonna utilize negative for the switch. So that works. So now I'm gonna see if that panel from the inverter can go somewhere close to this screen, so I can see it from outside. And that's all I need to do on the front panel. Well, as of now, you can always customize it further. So we're gonna let me put that panel up, and then put this one where properly, so we can see it. But actually, I'm gonna remove the BMS for now, because this is positive, this is negative. I don't want it to short, so I'm gonna remove this. I was just testing it if the wire can go through after this panel closes, which it does. Okay, so for this BMS, it's a EC BMS. So I got this for my 15S battery. So here's the wiring diagram. I hope whoever wants to get inspired with this video and want to do it on their own. So how to wire these. So here are the main wires. So for 15S, so you have 16 wires altogether, from black to red, and everything in between, white. So 16 wires. So because of 15S. So to hook up, because this one goes up to 24S. If you can see C24. Ooh, focus. No, whatever. No, whatever. Doesn't matter. Here. So C24. So here's the wiring diagram that follows. So let's see, like this, right? So from right, it's a C0, and all the way to left C24. So since I have not 24 in series, I only have 15 in series. So I need to follow this route wiring. So in the first all these wires, these ones are like this. So the last one, not the main C0, but C11 and 12, I need to connect them together and attach it to my 11th cell, positive. Onwards, in the center wires are for the temperature sensors, which they have provided right there. So I'm just gonna attach it later at the end. But for the after the 11th battery, which will take the 12th C12, we need to do 13, which will connect to 12th, 14, which will connect to 13th, 15th, which will connect to 14th battery, and the last one, C16 and C24. The rest from 17 to 23, they're useless. It says no connection. So 16 and 24, we need to make a connection of that, and then we'll have to connect it with the main red positive at the last one. But don't follow this unless you have the same BMS. Every BMS has a different way of connecting the wire, so you always have to follow the manual. So this one is for, this procedure is for this specific BMS. If you have DALI BMS or ANT BMS, not ANT, but DALI BMS or any other BMS, regular BMS, usually this one would have worked like in a straight row. Mostly, if you can get 15S BMS, that's how it's going to be. But if you get 24S BMS or 20S BMS, which is compatible with any other series below that number, then there's always some kind of a way of connecting a couple of wires and leaving some wires behind to make it work. So that's going to be with this one, and that's going to take a lot of time because I have to cut one wire at a time and then connect it with the one wire here, and then I have to do a shrink wrap all the wires to make sure they don't touch each other. So I'm gonna cut the video and then do all the wiring of the BMS, and then I'll just show you the end result, because no point of showing you, because most likely you're not gonna use the same BMS. But that's how this BMS works. But most of the BMS, if you get more in series, like 24 or 20S in series BMS, which is compatible with any other, that there's always some kind of a stupid way of wiring it up properly. So always follow the instructions from the manufacturer. Okay, so I'm not going to bore you with the procedure of this one because it's specific to this. But easy way, if you're going to do this, just get the 15S BMS. If you can't, which is very hard to be honest, that's why I got this 24S BMS, and then just because it was easy to do the wiring. So I'm like, okay, let's do that, because it's easier. It's cheaper and easier to get the higher SBMS as long as they're compatible. And it's kind of hard to find the 15S BMS. 17S on a lithium-ion NMC, no problem. 20S, no problem. 24S, no problem. But yeah, 15S on a lithium-ion phosphate is kind of hard. So this one is a smart BMS with the Bluetooth, so I can always I can always change the parameters, and as long as the wirings are done properly. So let's do that, and I'll show you the end result, because as I said, no point of showing you the whole procedure of the specific BMS. Okay guys, so the BMS has been installed, all the wires. It's a little bit of a mess, but that's okay. There's going to be a cover on it. So now with the switch, it's going on that side, and this wire is coming in from the switch, and it's going into the B minus of BMS, and that's where the power comes out of BMS. So with my voltmeter right there, I put my prongs on the positive from the main battery direct, and if I touch this, let's see, it's showing 0 voltage, and the reason is because the switch is off. The power switch that we just, not the power, the main safety switch. So when I turn that on, then it should show 49.9 or 49.8 volts. So let's turn it on and see if it's working. So then on this side, and this is the switch. So now the battery is on, No, my prong and minus. Okay, that's interesting. How come it's not showing the voltage? Where did I miss something? Ah, it says V plus. Do I need to put the wire in for positive? Oh, I might be missing this. Okay, so I need to make a connection, very thin wire, I guess, just to turn on the BMS. I'm gonna check the manual one more time. If this needs to be connected, then I guess then we will get the voltage. Okay, let's find out from the manual. Well, actually, I didn't even check the manual. I just noticed my prong was not connected because I'm holding one with one hand with the camera, and so this one I was just letting it sit, but it was not connected. It was like this. So the plastic was touching, the prong was not. Okay, so now if I do it this way, now the metal is metal, and this is the battery minus. So if I do this, so this is 49, but this is direct, it's not coming from, so it's going to the BMS. So this one is the output. So if I touch this, see, 49.8. So there. But since I just saw this V plus, I'm gonna check if this needs to be connected anyway with the manual. But for now, my voltage, it's working. So the BMS is working. And if you notice, there's some lights going on. It's balancing itself, I guess. I'm gonna check the app as well. But it looks like it is a smart BMS with balancing feature, so it must be doing the balancing right away. But yeah, so far that's how it looks like. It's a lot of work, but I guess it's gonna worth it at the end. So after this, this connection, this is coming from the inverter. I'm gonna have to make a connection out of a XT90, positive to positive, negative to this P minus there, and this one should turn on afterwards. After that, I need to use this wire to put the switch for the inverter at the back to remotely turn it on, because if I put the wires in, it will not turn on its own. There's no always on switch on this inverter. You have to manually turn it on every single time. So I'm gonna have to put that at the back. So I'm gonna have to open up this panel. So with that, I'll also remove those bus bars. So yeah, so it's gonna take a couple of parts, I guess, to make this video for this whole project. But I just do it in stages. I don't do it in one shot. So I always keep thinking something new. But until you do all this, you won't find a way. After that, I also need to put these fans on with the DC converter. So these are 12-volt fans. So this side is exhaust, that side is intake. So I already put the fan, I just rotated it so the wire was going into that area. So I removed these 4 screws, I turn it around, so now the wire is coming this way, and this one is right here. So I'm gonna make a connection, red to red, black to black. I think the white is a sense wires, but you don't need to connect that if you're doing it direct. So this one, I'm gonna put them together and then make a switch at the back. So every time I turn on the inverter, I will also turn on the fans for the ventilation. But that will be on the next video, I guess, or the following video. So so stay tuned for this another part, and we'll continue later. Okay guys, so far I plugged in the main positive of the inverter, negative of the inverter coming in and going into the BMS, BMS negative coming in from the switch, which is turned on at the moment, and these are the balancing wires. The fan, I connected black to black and red to red, oh, it's underneath, but it's of course not, there's no power source at the moment, because I'm gonna put the DC to DC later. Did okay. I zip tied, so the BMS not going anywhere. So the back panel, I'll still have to remove it to put that switch for the inverter. But for now, just for testing purposes, everything is plugged in, everything has power. So if you can see, there's a light for the inverter, and the display I had to cut a little bit because the wire was like a bit short. So I'm gonna tape this so it doesn't get cut with the metal, but it's coming into the display, and display is showing like this. So it's 49.8 volts, 125 volts AC. And to test it, let's plug in the heater. So if I plug in to one of the outlets and I turn it on, let's see, 311 watts, and it is working. So let's try other outlet. Yeah. See? Let's try the third one. And let's try the fourth one. Yeah. So everything is working. This is also powered, 30 amp one, even though it's not going to provide 30 amps, but it is powered at the moment. So if I, not that I ever will, but for whatever reason, if I do have to use it, I'll just have to make sure that it's 2000 watts max. So for now, that's what I've done. So I still need to make a connection for the positive from here to the battery, which I'll do later, of course, not a big deal, because I'm not finished yet. Just wanted to test everything, and everything seems to be working. It's just inverter and a switch. Fans, of course, I'll have to do DC to DC, and a switch at the back, which we will do when we do. So yeah, seems like I'm gonna put it to charge. For charging, I'm gonna put the main wire, main positive. I'm gonna take the main positive, and I'm gonna take power negative, and then the charger will work. So I'm gonna test that for now, but for the rest of the unit, everything seems to be working. Okay, guys. So at the back, so you remove 4 screws either side, and there are 2 screws on this side. So you remove those 4, 4, 8, 10 screws, and the panel just comes out, the back panel. So here's how it looks. So as I mentioned earlier, so I'm gonna remove all these bus bars. Yes, I'm just gonna remove this board, and they're gonna come with it because they're all screwed. So screwed in. So I'm just gonna remove those, and that will give me a lot of space to do whatever I want. Okay, and this is the board that came out. So I removed all the bus bars and whatever the connection points were. So this is what came out. So I'm gonna keep the charging ports because I'm gonna charge it from there. I'm thinking of charging it from there. So I'm most likely gonna either utilize that and that, which is this is just a reset button which is connected to one of those. So technically I'm not gonna remove any of that. I'm probably gonna use these spaces for something, probably the switch that I need for my inverter. So that, if I remove this, whoops, so somehow I need to utilize these 2 spaces, or just do it from the back, I guess, something like this. Whoops. Oh, not easy with one hand. Something like this. So anyway, I'll figure it out, and I'll see how that goes. Okay, so what I ended up doing, instead of using those external battery ports, I used the grill So I made a hole in the grill right there, and I zip tied my switch, and it does close. It does close. It just takes a little bit of a resistance, very little, just because of this wire. It bends right there, you know, where the corner is just too far out, but it still closes. So and it works because I checked it with the turning on the switch from here after closing. I didn't put the screws in yet, but I was just checking it, and it does line up. The screws line up everything. So a little bit of resistance, but it does work. So once everything is aligned, it right there, so it does close. So I'm not gonna screw up right now because I still need to put the wires for the charging ports. So but yeah, it does work. And then if later I find any Ethernet wire with a very thin connector, then I'll just replace the wire later, because there's a bunch of wires here, which I'm gonna store it here. But if I find a smaller, thinner wire, especially the connector, then I'll just replace it. Okay, so here's what I'm thinking. For charging, I already have that connected for the inverter. For charging, I'm gonna keep that. I'm gonna remove this, and instead I'm gonna install this barrel connector. I think it's 5521 or 5.5 times 2x1. So to remove this, here there's glue here and on this side. So you remove that glue with the knife or whatever, and then you just make sure that it just wiggles. It's not gonna come out yet. So here there is a ring, so you just rotate it anti-clockwise. Oh, it comes out, and you just push it. Oh, there you go. See, it fell right there. So now I have a hole where I can put this barrel connector there. Oh, sorry, I cannot see it. There, and then I can screw it on with this. So I hope the size works. If not, then I can always melt it a little bit to make it work. So let's put it together and see if it works. Okay, it is a teeny tiny bit short or small for my connector to go inside this. So I'm just gonna melt. So I'm letting it warm. So once it warms up my soldering iron, I'm just gonna melt it a little bit, so I can put that connector in snugly, and then that will be secured. Okay, just a little bit of melting, very slightly, and then it went in. So now I'm just gonna secure this connector at the back with this. So like this. So you make it go through this. I'm gonna cut this one off anyway, and then you just twist it, and then it will be secured. But it's already too tight anyway, so even if I don't do this or just put a glue, it's good enough. I'm gonna change the wires because these are very thin wires. Even though I'm not gonna use this specific point of charging, I'm gonna make all of them charging points. But this one, I'm gonna make it I'm gonna change the wires a little bit more thick wires. But for now, that's okay. But I'm gonna change all the wires. I'm gonna put the thicker wires on all. So here's what I ended up doing. So with the barrel 5521, I made a connection with the thicker wires going onto this whatever connector it is. So negative to negative, positive to positive, and onwards the same, negative to negative, positive to positive. This is XT60. This is the normal, whatever it's called, like this one, the 3-prong one. So all three, so XT60, this prong one, and 5521, they all have the same wire now. Of course, I'm not gonna do double charge, like two chargers at the same time. So one charging at the same, one charger will be connected. So these wires are thick enough for that. So most likely I'm gonna use 5 amps It will take a long time, but again, I'm not in a hurry or anything else. If I want to do ever solar, then we'll have to do a solar charge controller, and then the wires will still come in. Not with these. I'm probably gonna utilize thicker wires from here, but at the moment I'm not doing solar charging or planning to do solar for now, so this is gonna be good enough. So all now is gonna be XT60. So I'm gonna take a male connector and connect it with this, and those male connectors will connect to the other side, will connect straight to the inverter lines, because they are coming in from the BMS. So that's how it will charge. So let's put this back panel back to the unit and continue on. Guys, this is the final product. I installed on this side a switch, and the wire is going on this side right here and to these fans. So finally I parallel connected all these fans, all the reds together, blacks together, and they're coming up here. So the switch is stopping the red wire to give power unless it's it's pressed, and then that is going straight to DC to DC converter, and that DC to DC converter is getting source from the main terminals of the inverter or the battery, doesn't matter, it's the same thing. So right now, as long as the main power switch is on, and if I press this, see the fan turns on. The fans, they all turn on at the same time, and if I click it again, they stop. So that will help. So these ones are intakes because they take the air inside, and those are exhaust, so air goes out. So with that, I also connected the charging wires going straight to the terminal wires, and this is I'm using XT60 to power, so I'm giving 5 amps, 250 or 60 amps, watts are going right now into the battery, and it's being charged. So since all of these are parallel connected, DC, these 3 sprung and this 5521, so I can use either or any of them to charge the battery. They all have the same single wire going into the terminal wires, and that is going through the BMS to the battery, and that's all. So now all I need to do now is put the covers back on, and everything is done. So to turn the inverter on, since it's already main switch is already on, so I put the switch here, right here. So if I press this, you will see this main power. It takes like 5 seconds to get the voltages. There you go, output volt 125 60 hertz. So everything's, and then if I press it again, it will turn off the inverter. So there you go. So now to put the cover back on, I'm going to put the cover back, and there's 2 screws to secure this. Same thing on the other side, and on top one it has like 12 or that one 12 to 14 screws. So let me just put everything back together and take a final video, and so I'll show you the final product. So here's the final product. So that's the main power. Here's the fan. So main power is on. You turn on the fan. All 4 fans turn on. There's the intake, and other side of the exhaust. Turn it off. This is on. Everything is sealed, so we'll turn this on in a second. So we go at the back. We turn on the switch. and everything works. We'll turn it off, and it's still being charged at 2 amps. Just taking it a little slow.